Thanks for watching this video. In this video, I'm going to present my paper. Its name is Domain Shadowing, Leveraging Content Delivery Networks for Robust Blocking-Resistant Communications. My name is Mingkui Wei. I'm assistant professor in cybersecurity engineering department in George Mason University, and I'm a single author of this paper. Here's the layout of my presentation. First, I'm going to briefly introduce what is domain shadowing, and then I'm going to discuss about how domain shadowing works. And after that, I'm going to briefly talk about the domain shadowing from the perspective of performance, security, and blocking resistance. And lastly, I'm going to conclude my presentation. But first, what is domain shadowing? Simply put, domain shadowing is a novel censorship evasion technique that uses content delivery networks. If you work in the field of censorship evasion, you must know domain fronting. So domain shadowing is similar to, but different from domain fronting in these two perspectives. First, domain shadowing can use one CDN to visit any websites. It doesn't matter if these websites are on the same CDN or not, and it doesn't matter if this website is using CDN at all. As a comparison, domain fronting, it requires the visited website shares the same CDN at the front domain. For second, domain shadowing exploits a legitimate CDN feature, which makes it harder to be blocked. Then let's look at how domain shadowing works. To understand how domain shadowing works, we first have to understand how CDN works. So content delivery network, basically a CDN is a shared web cache. Here I'll give a very simple example. So let's say here, I have a content provider. The content provider has this web server here, but the content provider wants to serve all the users across the world. So what the content provider can do is the provider can use a CDN service. So CDN service has a lot of cache servers distributed across the world, which can cache a web document and use a cached web document to serve local users. So besides a web cache, a CDN also serves as a name server, which handles domain name transformation. So based on the previous example, here is what happens. So let's further assume this content provider has a domain. It runs a service on AWS, and it got a canonical domain, which is abc.aws.com. But the content provider doesn't want to advertise this domain. It doesn't want other users to visit its websites using this domain. Instead, the content provider wants users to use this example.com such that when the user enters example.com, it can be directed to this website. So what the content provider can do is it can go into the CDN and configure the example.com as the front end of the CDN and abc.aws.com as the back end of the CDN service, such that when the user visits example.com, the request will be sent to this cache server, and the cache server is going to access abc.aws.com on behalf of this user. In this and the next slide, I'm going to briefly introduce how domain name transformation happens inside a CDN. This shows a Fastly version. Fastly is a CDN provider, is a big CDN provider in North America. So let's follow these 8 steps. The server, when the user wants to visit example.com, a DNS query will be sent to name server. Let's assume it's GoDaddy. GoDaddy is going to resolve example.com into global.ssl.fastly.net, which is a subdomain belongs to Fastly. The second DNS query will be sent to a Fastly's name server, which will be resolved to an IP address that belongs to one of Fastly's edge server or cache servers. But then the user is going to send a request to this edge server and asking the content of example.com. So when this edge server receives this request, the edge server is going to access abc.aws.com, which has been pre-configured by the user. And when the response is received from abc.aws.com, the content will be repackaged under the name of example.com and sent back to the user. This slide shows a slightly different version, which is conducted by Cloudflare, which is another CDN provider. So Cloudflare has its own name server, which will skip 2 steps actually. So the user will directly send the DNS query about example.com to Cloudflare's name server. And this Cloudflare's name server is going to directly respond with IP address that belongs to one of Cloudflare's edge server. Then the user is going to again send this request to example.com. the edge server is going to retrieve this document, and when it's received, it will send it back to the user, again, under the name of example.com. So what makes things interesting is during this whole process, okay, so either the user or a censor, if we assume there's a censor who can oversee all this traffic, either the user or censor knows what is happening inside the CDN. So the user and censor who looks at this traffic only knows that the user is communicating with CDN and asking about example.com. So what they don't know is this example.com is actually transformed into abc.aws.com. So this transformation is only known to the CDN and to the domain owner who has configured this. So based on this, a user can evade a censorship using CDN with these 5 steps. So first, the user is going to register a new domain. Let's say it's a shadow.com, and we assume that this new domain is not blocked because it's brand new. And then the user is going to subscribe to a CDN service that is not censored. Then in the CDN, the user is going to set shadow.com as a front end and the blocked.com as a back end. Here we assume blocked.com is a censored domain that cannot be accessed. And after all set, the user can visit the blocked or censored domain by visiting the shadow domain. So basically, the user can enter shadow.com in his browser, and then the blocked.com content will appear in the browser. And what makes things better is all above configuration steps can actually be handled by a browser extension, which we have implemented as a prototype based on Firefox. And of course, as you can imagine, there are a lot of details about configurations, which I skip because of time limit. And if you're interested, you can find all the details in my paper. And here I will directly jump to the result. So what we have done, we have registered a domain, which is domain-shadowing.net, and we have linked it to facebook.com. And we have tested from a censored country which blocks facebook.com. And in our experiment, we also use the technique of domain fronting, and we have chosen forbis.com as a front domain. So here shows what we have done. So basically, we have sent a request to forbis.com, but in the request, we have changed the host header into domain-shadowing.net. So this request is sent to the CDN, and in the CDN, we have configured to connect domain-shadowing.net to facebook.com. So then the edge server is going to fetch the web document from facebook.com and get a response, and then send it back to the user in the name of forbis.com. Here's the result. Okay, so first, it shows that we can successfully access Facebook from within the censored country. Okay, second, I want to bring to your attention this. If you look at here, so it actually shows the front domain, which is www.forbis.com, but the content, as you see, is from Facebook. So next, I'm going to briefly talk about performance. So in this experiment, we use different approaches to fetch the same document 200 times. We basically use 4 different approaches. So we use domain shadowing, we use Siphon, which is a popular free VPN-based censorship tool, a censorship evasion tool. We also use 2 VPS-based approach, which basically we rented a Linux instance on AWS, and we ran a HTTP proxy based on that. And we also compare with directly accessing the website. So as we can see here, so basically all the domain shadowing based on 5 different CDNs, their performance is much better than either Siphon or VPS-based, and even better than than directly access. So this line shows the CDF of all these 200 document fetches. You see here is a shortest time consumed. Okay, so next, I'm going to briefly talk about security. So domain shadowing does bring some security concerns, and the root cause of such security concerns is because the domain name transformation that happens in domain shadowing confuses the browser, which may allow cross-domain attacks. So basically what happens is, as in here, the browser thinks it is visiting forbis.com, but the content and including all the response headers are actually from Facebook. So because of this, the browser can no longer enforce the same origin policy, which makes possible of cross-site scripting and cookies and session hijacking. Okay, so a solution, basically we can integrate some countermeasures into the browser extension. And we can also do some user education. We can tell the user what are suggested, what are not suggested to do. But the ultimate solution would be we have to dive deeper in the browser and modify the browser, which is not impossible, but requires a little bit more labor. So one example would be the Tor browser, which is a highly customized browser based on Firefox. Okay, so lastly, I'm going to talk about blocking resistance. So domain shadowing is made possible because the CDN allows a user to set any domain at the backend. Okay, but this is a legitimate feature of CDN. So CDN needs this to work. Therefore, CDN cannot easily disallow it because it's gonna harm CDN. And on the other hand, censored can see nothing but a normal communication between the user and the shadow.com, as I've shown before, as long as HTTPS is used. And of course, censored can do like a traffic analysis and website fingerprinting, but this technique is not mature, and also it is not impossible to circumvent. And again, also the CDN by itself can identify the user domain shadowing, but the identification doesn't come for free. The CDN has to spend significant effort and time to identify it. So essentially, the identification is a kind of like a endless arms race. So CDN can do a countermeasure, but then we can find a countermeasure and so on and so forth. Okay, so to wrap up, domain shadowing is a single user censorship evasion solution. So the user is going to handle everything as I've shown before. And this solution doesn't require any dedicated third party. So there's no other party to support you to evade this censorship. And it also doesn't need a collaboration from the censored website. And it is lightweight because it only relies on a simple web browser extension. And it has better performance, as I'm shown. It is faster than most VPS-based or even direct access. And it is harder to block because it utilizes a legitimate feature of the CDN. And without this feature, the CDN won't work, or at least the CDN gonna sacrifice a lot to work. And because of time limit, I'm skipping a lot of details. And if you're interested, you can always find all the details in my paper. So thanks for watching this video. And if you have any question, feel free to send an email to me. Here is my email. And thank you again for watching this video. Bye.